Alright, now that we're done with that, let me just save my progress. Boom. And now we go to the next section where we implement an AI customer service agent that reliably determines when to get human intervention. So, first let's copy all of the code and then I'll walk you through it. This would be an agent's customer service. Okay. And then test file. Perfect. And then we have the script for the test. And lastly, the build file. So, time to walk through the code. Alright, okay. So first we just have a data class to store one conversation message. Then we have another data class to get the entire conversation history, and when it gets that, if a customer has sent any message, it appends this customer prefix, otherwise the agent prefix. When it comes to the actual agent, it initializes with your Anthropic API key, which builds on the Claude client we built earlier. The evaluate transfer need is where the magic with MCP happens. So we have a response schema given the user's conversation history, so the messages sent by the user. The response schema asks for transfer needed, which is a Boolean. Transfer needed being a Boolean is really important for other code to take action based on this result. We ask for reasoning. We also ask Claude to detect a primary emotion chosen from these 8 feelings. We also ask Claude to detect the intensity of the primary emotion and the confidence with which both of these are detected. And of course, everything is required. And then the system prompt to Claude is this, where we basically tell Claude that, hey, urgent issues or any immediacy or high or medium intensity should be relayed to a human right away. And if there are any special topics such as billing or payment disputes or cybersecurity issues or anything like that, don't worry too much, get a human involved. The idea is we want to understand both human emotion as well as the circumstances in hand, because in extremely dire circumstances, there isn't enough time to communicate that properly to any customer service agent out there. All right, and then we have a generate response function. So this is the response that would be shown to the user, not generated by Claude, in an effort to keep the costs down and make it more accessible. Right now, we just have a placeholder response. We will revisit this later towards the end of the blog. And then this is the function that processes a user's message. So once it receives a user's message or a customer's message, it calls the evaluate transfer need function that we discussed earlier. And then it extracts whether Claude recommended a transfer or not, and then it proceeds accordingly. And then we have 2 types of tests. First is this run test conversation, where it just processes one conversation and reports back when did the agent decide to get a human involved, whether it is after the first message, second message, or third message, or fourth message, or never. And then we have multiple test function, which executes the run test conversation function on each of the tests provided to it. Now, the main of this file, it just loads all of the keys, initializes the agent, and then it has 2 tests. Let me comment this one out first. This one is just a sample test conversation. Remember, Claude doesn't get the response shown to the customer. It solely focuses on the messages sent by the human customer. So this is just a sample scenario, and then we're gonna run the test conversation function. Let's comment the multiple tests out one for now. And then with this conversation, even though there are 4 messages, we expect a human to be reached out to after the 3rd sentence. So the 4th sentence isn't even sent or processed by Claude before determining whether a human should be reached out to. And to run this, we will just copy this code. Perfect. We have a answer from Claude, and it did transfer the conversation right when it was expected to. This is a conversation history. If you don't want to see the entire conversation history, just turn this verbosity flag to false. And this is how you test one conversation. Now, I did create this test conversations JSON file. It groups conversations based on whether they should be transferred to a human after the first message itself, if it's ultra urgent or highly sensitive, or whether it's just beyond AI capabilities. So this is a transfer on first message category. Then we also have transfer on second message category. And lastly, we also have transfer on third message category. You'll see that some of the transfer and third message categories have 4 messages. The idea is we're not just waiting for all messages to get over before asking for a human to intervene. We're just evaluating based on the quality of the conversation and the content. We have about 4 transfer on third message tests, 10 transfer on second message tests, and 10 transfer on first message tests. To run this, just comment out the first test and just uncomment this line. And you just use the last command to run the test. Now this is a long test because run multiple tests, take those 24 conversation test messages that we have, and then it iterates over them 4 times. The idea here isn't whether the test passes or fails, but rather if a test passes, does it always pass, or if a test fails, it always fails. So while this test is running, I did run this test before, and this is what the output looks like. As you can see, 24 tests times 4 is 96, and yes, all of them pass, which is good. But again, more important is that all of them have consistently passed. And not just for these 4 times, I have run this script about 5 times, and I've still always gotten the same results. Perfect. Does this guarantee reliability? Well, for that, we need to do further research, but some of the tips and tricks that I've used is number 1, setting up temperature to 0 to reduce randomness, and again, only focusing on users' conversations. And number 3 is using MCP, because when we specify to Claude to understand human emotion, we're also nudging Claude to think along those lines, so we have better reasoning from Claude therein.